right, so example 4 here looks a lot like example 3. You'll see what happens though. So it's not always going to work out. Just like when you solve systems 2 by 2, right? Getting one solution is not always what happens. Sometimes it can be infinite solutions. Sometimes it can be no solution. So let's take a look at what happens with this one and what that's going to look like on your end. So first we convert the equations into the matrix. You input the matrix like we just learned on the last example. We use that reduced row echelon form function, and this is what ends up happening. Notice how what's on the left side here is not the reduced row echelon form. You got an extra -3 up here, and it's all zeros on the bottom, right? So if you were to break those out, these are the equations that you would get: x minus 3z equals 4, y equals 0, and then 0 equals 0. What that would look like if you actually graphed it. There's only 2 planes, right? And again, when we're talking about a 3 by 3 matrix, we're talking about not a coordinate plane, but a coordinate space, 3-dimensional. So you have your x, your y, and then you also have a third dimension, z. So that's why we're talking about planes and not lines. So what's happening here is there's only 2 planes and they intersect, and where they intersect is a line. There's only an infinite amount of places where points on that line, right? So it's not saying like all real numbers are answers. What it's saying is there's an infinite amount of answers. So again, yeah, there are infinitely many solutions to this system of equations. All right, so what you should focus on is what it looks like here. And what you got is something that, is not the reduced row echelon form. So let's take a look at what's going to happen here. We're going to input that in to the calculator just like we did in the last example. All right, so we got the calculator open. We're going to enter it in just the same. I still have my A and B from last time. So what I'm going to do from last example, I'm just going to type in over top of the A. All right. So just go over to edit, hit enter on that. It'll pull you into a screen. Well, I want the same dimensions, so I'm just going to hit enter twice to get down to the elements. And then I'm just going to start typing over them. X here is 1, so 1's already in there. So let's hit enter. The next one's going to be -2. I can just type over it, hit enter, and then the new number will pop up here. Z is 1 in this example, so that's already good. And then I want 8. And it pops down to the next row. -2, hit enter. 4, hit enter. -2, hit enter. And then 16. The last row, 1 is good. 2 is good. And then -1. And then -8. So really the majority of the time for these examples now is really just inputting all the numbers. All right, so then we're going to quit out. We're going to do second matrix. I forget the numbers, we're going to have to scroll down. We're looking for that reduced row echelon form, so it's B. All right, so RREF, pull that down, and we want to do this now for the matrix that I input into A, so we'll just hit enter on that. Close the parentheses, although you don't actually have to do that. I just like to do that. And there you go. What it looks like is pretty similar to what happened on the last one. So if we look at it, that means x equals 0, right? There are no, so basically this is another situation where there is no solution. And the reason why there's no solution, as opposed to infinite solutions, is there's false statements here. Well, this top one could just be simply x equals 0. This could be 1y minus half of a z equals 0. I mean, that's conceivably could be true, but look what happens down here, where you have no variables. So the left side of the equation is 0, and the right side of the equation is 1. So you get 0 equals 1 for this third equation. That's a false statement. Since 0 does not equal 1, it's the situation where we're going to say then there's no solution. All right. So if what you get in your results is a true statement where things just cancel out or whatever, then it's infinite solutions. This is a situation where it's no solution because 0 does not equal 1. All right. Let's go ahead and look at the last one. We'll need to rewrite the equations. Looks like actually just the middle one, right? So we're going to bring, what I would do is just bring the y over to the right side and then flip the whole thing around. So it would be still 6x minus 2y plus 4z, and that's going to equal 28. So really you just had to bring one term to the other side, and then you just flip the entire equation. When I go ahead and enter those into the calculator, it's easier to work with here. We'll do second matrix. We'll go over to edit. I'm going to input this one into B. It is still going to be a 3 by 4, so that's good. We got 0.9, negative 0.3, 0.6, and then 4.2. And we have 2. No, we don't. We have 6, negative 2, 4, and then 28. And the last equation is 3, negative 1, 2, 14. We'll quit out of that. I can just do a second entry because I want that function anyway. We'll just switch it out for the b function. And by the way, if you just typed it into the a function, then you can just not even have to pull that b part down again. You could just redo the a if you had copied over a. All right, so this one's a little harder to see because we have a long repeating decimal there, which essentially just means negative 1/3. But what I notice is on that bottom row, it's all zeros. See, as I scroll back and forth, it's all zeros in the bottom row. So this is more like the previous example. So you get things that cancel out, and you get some nonsense equations, but you're getting that 0 equals 0. So this would be an infinite solution situation. All right. Hopefully that makes sense. Like I said on the last example, the fifth example here is just going to be using some of the stuff in context, and we will be using the calculator method for that. So let me know if you have any questions.